Okay, so let's go over some terms that we're about to use. A factor, or two-factor, is to break up a polynomial into a product of polynomials that can be multiplied to get the original polynomial. That's called factoring. The greatest common factor is the largest number that is a factor of two or more numbers. A factor is just a number that divides a number evenly, so that's B. Equivalent expressions, they're expressions that have the same value, and so that leaves C. Distributive property is the property stating that the product of a factor times a given quantity containing the sum or difference is equal to the sum or difference of the products of that factor times each term from within the quantity. So that is just ridiculous in terms of trying to understand it without the numbers, but we'll talk our way through that. Okay, so let's talk specifically about greatest common factor. So that is the largest number that can evenly divide into two numbers, okay, into both numbers. So what's the greatest common factor? What is the GCF of 36 and 45? Well, here, let's make a factor tree. So here's our factor tree for 36 and for 45. You can see that when we get to the end, we have two twos and two threes, right? 4 times 9 makes 36. 4 is made up of 2 times 2, and 9 is made up of 3 times 3. So let's do the same thing for 45. For 45, we have 3 times 15, and 15 is made up of 3 times 5. So what do they have in common? Well, let's see. For 36, we've got 2 times 2 and 3 times 3. For 45, we've got 3 times 3 and times 5, right? We've got these numbers here, 3 times 3 and 3 times 5. So what do they have in common? They have in common these two 3's. So the GCF is 3 times 3, which is 9. Okay. The GCF for two monomials is a little bit more difficult when we're working with monomials. We have to get the GCF not just for the number out front, that's called the coefficient, not just for the coefficient, but also for the variables. So we have to do it for both. So, for example, if we were looking at these two monomials, we're trying to find the greatest common factor. Let's start with the coefficients, and let's make our factor tree, right? We've got 3 times 4, that's 36. Well, 9 is made up of, or rather 9 times 4 is 36. 9 is made up of 3 times 3 and 2 times 2, right? And 45, let's make our factor tree. We've got 9 times 5, that makes 45. And 9 is made up of 3 times 3. So their greatest common factor, they share this 3 times 3, right? That's 9. So the greatest common factor for 36 and 45, that's 9, right? We did this in the last page. When we're talking about the variables, let's look at the variables now. And when we're talking about the variables, we're looking at the powers, and we're thinking, okay, what do they have in common? X to the third, that's 3 times 3 times 3. And x to the fourth, that's x times x times x, right? So x to the third is x times x times x, sorry. And x to the fourth is x times x times x times x, right? There's an extra x on there. That's what x to the fourth means. So what do they have in common? They have in common these 3 x's right here. So x to the third is what is common for the variables. That's the greatest common factor of those variables. So now when we're looking at the GCF, the greatest common factor for both, right, for these monomials, it's 9 times x to the third. In other words, 9x to the third. That's the greatest common factor. What is the GCF of 72a squared times b to the fifth and 27a to the third times b to the third? Okay, well, let's start with the coefficients, right? Let's start with 72 and 27. Let's do a factor tree. So here's our factor tree, and you can see that I've got, at the end for 72, I've got 3 times 3 and 2 times 2 and another 2, right? For 27, I've just got 3 times 3 times 3. So what do they have in common? Well, they've got 2 3s in common. They've got 2 3s that are common to both. So the greatest common factor is 3 times 3, which is 9. All right, so the greatest common factor of those two numbers is 9. Let's look at the variables. So a squared, we're working with the a's first. A squared and a to the third, the greatest common factor between a times a, and that's a squared, right? A times a. And a to the third is a times a times a. What they have in common are these two a's. So a squared is the greatest common factor there. All right, let's do the b's. So the b's, we've got b to the fifth and b to the third. So b to the fifth, that would be b times b times b times b times b. And b to the third, that would be b times b times b. So they have in common these 3 b's. So b to the third would be the greatest common factor. So we put them all together now to get the greatest common factor of these two large monomials. It's 9a squared b to the third. We put them all together. That's the greatest common factor. Okay, so let's take another look at a GCF of a very complex monomial, a set of monomials here. So 27, we have 27 and 18 and 33. So 27, let's make a factor tree for that. So 27, what you got in 27 is 9 and 3, right? 9 times 3 is 27. And then 3 times 3 is 9. So I've got 3 3s. That would make 27. All right, 18. Let's make a factor tree for 18. That would be 9 times 2, and 9 is made up of 3 times 3. So I've got 2 times 3 times 3. That's 18. And then 33, there's not too many ways to make 33. It would just be 3 times 11, right? That'd pretty much be it. 1 times 33 and 3 times 11. Those are the only ways you could make one. So I've got these numbers all factored out. I know what goes into them. And now I'm just looking for what is common. What's common is this 3. I can only have 1 3 in common because of this 33 right here. It only has 1 3 in common. So 3 is the greatest common factor of these 3 monomials. All right, so that's the first part. And then for g to the fourth, g to the second, and g to the sixth, the greatest common factor would be g to the second. G to the second would be the greatest common factor. And we could do it out like we did before, but what you need to, the pattern you need to discern at this point is that it's the variable with the lowest power. That's the greatest common factor. So let's look at the h's now. So with the h's, I've got h to the fourth, and I've got h to the fifth, and I've got no h on the last one, right? Okay, so for these, the greatest common factor, because that last term does not have an h, there is no h in the greatest common factor. If there's no h in this last term, there can't be an h in the greatest common factor. And the greatest common factor would therefore be 3, right? 3 times g squared. It would be 3g squared.